Good morning. The last class we discussing about types of engineering analysis. We already see about a structural analysis and vibration analysis. Today class we discussing about the another analysis. We call it as a fatigue analysis. So the fatigue analysis help us to design to predict the life of the material or structures by showing the effect of cyclic loading. Okay. So for example, if you are applying the 1 hour, if I take as a 1 hour, I have to apply the repeated load on the object how their materials behave. So the engineering can be predict the material life and the quality and of the particular materials. And also they have to find out the properties of the materials. Okay. That is a showing of the cyclic loading. On the specimen, in such an analysis can shows the area where the crack is propagations. Okay. And is mostly like to occur. So failures due to fatigue may also show the damage of tolerance of the material. So it is the analysis. So where is the failures can be occur and where is the crack will be propagated for the particular specimen when we are to applying the types of load on the particular specimen. So after that, we are moving for this heat transfer analysis. It is one of the thermal analysis. Okay, so the heat transfer analysis model to conductivity or thermal fluid dynamics of the material or structures. This is may consist of the steady state or transient transfer. That is a steady state transfer refers to the constant thermal property in the material that is a yield linear heat diffusions. So these are the called as a types of engineering analysis. So let's move for the next topic. Is called as the how can the FEA helps to design engineers. So already we said this. That is the FEM is called as a finite element method. It can be offer the many important advantages to the engine design engineers. So what are the called as? One is the foremost thing easily applied to complex and irregular shape of object to compose the several different material and having a complex boundary conditions. So let's discussing what is the meaning of boundary condition. We are discussing on numerical problem also. The later on we discussing and also applicable to steady state and time dependent and eigenvalues. Eigenvalues. So applicable to linear or non-linear problem. One of the methods is can be solved the widely variety of problems is like a including problem in a solid mechanism or fluid mechanics, chemical reactions, and the electromagnetic and biomechanics and heat transfer, acoustics, to few name of the few. Okay, these are the different types of method to analysis. Okay, so whatever you have to take, okay, whatever you have to analysis, so the engineering can be predict the material life and the qualities. And also we have to study the applicable for either is like a linear or non-linear problem, and also they are to applicable to study the steady state or time dependent or eigenvalue of problem for the any complex surface or irregular shape of the object for the any different material or several different material. So it's the most thing we are to using for the engine designer, and also many advantages by using of FEA. The next one is how can the FEA helps to design organizations? So simulations is using of FEM. It also offer the important business advantages to the design organizations. The first of all, one is the reducing test and designing the cost, thereby shortening the product development time. So and also identify the issue in design before tooling the committer. Identify the issues if a design before tooling the committer, refine the component before the deficiency to other component propagate to change, and also optimize the performance before the prototypes. So discover the design problem before the litigations. Okay, and also main importance the cost wise is very simple. So before going to prototype, okay, we have to analyzing where is my problem is created, where is my deficiency increase created, where is my crack is propagated. So where is my very weaker parts in my design. So we have to analyzing all the points. So these are the called as a basic steps of FEM. So those are called as discretizations, selections of approximation functions, formation of element stiffness matrix, formation of total stiffness matrix, and the formation of loading matrix, and formation of total loading matrix, formation of overall equilibrium equation, implementation of boundary conditions, calculation of unknown nodal displacement, calculation of stresses and strain. So these are the, I think my point of view, these are the primary steps we have to do whenever you can analyzing any types of problem, any types of complex problem. These are the foremost steps we are to doing for your FEA analysis. So let's see, discussing on detailing the each and every step, how will you work on how will you working for the mathematical equations.